Okay, so in this video we're going to talk about nomenclature, specifically naming ionic compounds and naming molecular compounds. The first thing we're going to talk about is naming ionic compounds. So remember, an ionic compound is anything that's a combination of a metal and a nonmetal. If you look at a periodic table, those are sort of defined, and in the one in your book they're colored, but the ones on the left, in general, the left sort of 2/3 or a little more down into the left are going to be the metals, and up and to the right, that sort of corner over by the P block, those are going to be your nonmetals. So if you have one metal and one nonmetal, or ammonium in the place of a metal and some other nonmetals, then you can have an ionic compound. So simply you sort of give the name of the cation, the positive charge, and then the anion. And cations will generally just be the name of the element. So Na plus, for instance, is just going to be called sodium ion. So when you write it out, it would just be sodium. Transition metals, however, you have to specify the charge. So anything that's not in the first or second column has to be specified a charge by giving this Roman numeral here. So Fe2 plus is iron 2, and the reason is because iron could also form the Fe3 plus, which would be iron 3. And there would be no way to know, if you just called something iron nitrate, which iron ion you meant. So this helps sort of specify that level of explanation for the reader of the name to figure out, okay, this means iron 3, that means Fe3 plus. This is iron 2, that means Fe2 plus. There's sort of two exceptions to this as far as we're concerned, and that is that Ag plus, the silver ion, you can pretty much always just call silver ion. You won't have to put silver 1. The reason is it will really only form a +1 ion, and the other one is zinc is always going to be 2 plus. And so that would just be zinc ion. Okay, so if you had AgNO3, it would just say silver nitrate, for example. We're going to go over some examples in a minute. The second part of this is the anions. They're a lot simpler, okay, generally just the name of the element with "ide." So you take off the ending of the element name and you add "ide." So Cl minus, right, a negatively charged chlorine just becomes chloride. A negatively charged oxygen would just be oxide. Okay, and then you have polyatomic ions that need to be memorized. So you need to know that NO3 minus is nitrate. There's no other way to get there. So see the memorization sheet for those. Okay, so let's look at some examples of ionic nomenclature and how you name it. The first two, we're going to take the formula that we're given of the compound, and we're going to turn that into the name. And the second two, we're going to take a name and we're going to write out what the compound is. So the first one we're dealing with is Fe2O3. What we need to do is figure out sort of the charge on these elements here. If we look really quickly at this table, you can see that iron is in the transition metals, so we're going to have to figure out what the charge of that actually is. It can have multiple charges. The oxide, the oxygen over here, is right there, right? And no charge, -1 when it's in an ion, -2. So oxygen is going to be -2. Okay, so given that we know that, one of the ways to do this is simply say, okay, we know 2 minus. We have 3 of them, so that's a total of 6 minus, and therefore we have to have a 6 plus out of those 2 irons, so each iron has to be Fe3 plus. So now when we write it out, simply say, okay, that's going to be iron 3, that's the charge, oxide. The next problem we have, Na2CO3. Okay, if we look again at the table, Na is sitting right here in this first column. Those are the +1s, right? +1, +2, and these you have to sort of specify what they are. So knowing that, we can simply say, all right, we're dealing with an Na plus and a CO3 2 minus. That makes sense because there's 2 of those and a carbonate. So we now know that this is sodium, just the sodium ion. And the CO3 2 minus, we have to know from our memorization sheet, is carbonate. So we would just call this sodium carbonate. Next problem, magnesium sulfate, turning that back into a formula. So magnesium, look at the table, it's in the second column right here. so that's going to be a +2. And sulfate we know from our memorization sheet, so that means that the magnesium needs to be Mg2+. The sulfate is SO4 2-, right? To make an ionic compound, we need to neutralize the 2, 2+, 2-, no problem. So this is just MgSO4. And the last one, copper 1 nitride. Well, don't even need to look this one up on the table for the copper. We know that that is Cu+, okay, the copper 1 ion. For the nitride, if we look at it, no, this is not nitrate, it's nitride. Look over on the right here. You can see there's nitrogen, so this is -1, -2, -3 for the nitride. Oops, I moved the wrong thing. So we're simply going to say N3-, and that will therefore will need 3 of the copper pluses to equal the 3-, so it would be Cu3N. And that's how you name these ionic compounds. Okay, now we're going to look at naming molecular molecules. So there's a pretty simple formula for this. In some ways it's a little bit easier. The first thing you do is you give a number prefix and the first element. So if we were to look at CO2, this is the first element right here. We have monocarbon. Okay. In general, the mono gets dropped for the first one. You don't need to include that. So you would pretty much just say carbon. And then you need for the second one, you then add a number prefix for it, so however many there are, plus the second element, you change the ending to "ide." So in this case, we have 2 oxygens that are covalently bonded to that carbon, so you would say carbon 2 di, and then oxygen, drop the gin and add the ide, dioxide. Right, so we have a sort of not present but kind of there mono, assumed in if it's not spoken, carbon dioxide. Okay, so these are the sort of 4 things you need to hit when you're going through and naming that. And again, you can leave the mono off at the beginning. So let's do some examples of this. Okay, so the first example, NO2. Mono nitrogen at first, so instead of worrying about that, we're simply going to call it nitrogen. The next one is oxygen. There's 2 of them, di, ox, and then we change the ending to ide, nitrogen dioxide. N2O4. In this case, we need that number prefix, di, nitrogen, and then 4 oxygens, tetra, oops. Usually you're going to drop that A. If it's another vowel, it'll be tetroxide. Sometimes you'll see it written as tetraoxide in one thing. Tetra is technically the prefix there. And then if we look down at carbon tetrachloride, okay, so now we're going to go the other way. Carbon tetrachloride, well, carbon doesn't give us a number, must be mono. Carbon. Tetrachloride, 4 chlorides. Chloride, chlorine, Cl4. So CCl4 is carbon tetrachloride. And then the last one, tetraphosphorus decoxide. Well, you're going to start with tetraphosphorus, 4 of them, P4, deca, 10, oxides, O10. So there you go. That's how you name molecular molecules.